This next video we take a look at problem number 7. F of x is equal to the piecewise defined function of x squared minus 1 over x minus 1 for x not equal to 1 and 4 for x equal to 1. So it's obvious that the top branch x squared minus 1 over x minus 1 for x not equal to 1, that function does not have a value when x is equal to 1, because in the denominator, because x equal 1 would make the denominator equal to 0. However, we can factor and cancel, and we would get x plus 1 times x minus 1 over x minus 1. The x minus 1 factors would cancel, and we would be left with the expression x plus 1 as long as x is not equal to 1. And that might look like the graph, and that is exactly like the graph of y equals x plus 1, which is just a straight line, y equals x plus 1, except it has a hole at x equals 1, y equals 2. And instead at x equals 1, the value of the function is 4. So when we graph it like that, we can see that the limit as x approaches 1 of f of x definitely exists. The limit is 2. F of 1 exists means that the function is defined at x equals 1, and that value is 4. But part 3 says f is continuous at x equals 1, and that is not true. X is not continuous. I couldn't draw that curve and the point at 1, 4 without picking up my pencil. Or stated in another way, the value of the function does not equal the limit at x equals 2. At x equals 1. So even though the limit exists and the function is defined, but the limit and the function value are not the same, and so only 1 and 2, but not the third option, are correct. I'll scroll down. In question number 8, we're told that the graph of f of x is 4 over x squared minus 1, and we're asked, is there one vertical asymptote at x equals 1, vertical and horizontal asymptotes? So by factoring x squared minus 1 in the denominator, we get that 4 over x squared minus 1 would be equal to 4 over x plus 1 times x minus 1. And since neither of those factors in the denominator can be cancelled, therefore there has to be vertical asymptotes at x equals negative 1 and x equals 1. So if we look at the answer choices, one vertical asymptote, that cannot be true. B, the y-axis as a vertical asymptote, that would mean x equals 0 would be a vertical asymptote, and that's not true. Now so far, and then also we can see that E cannot be true. E says there are no asymptotes. Now in addition to having plus or minus 1 but no horizontal asymptotes, besides having plus and minus 1 as vertical asymptotes, we have to consider the horizontal asymptotes. A horizontal asymptote is just a limit at infinity. And if you just consider what happens when you put an infinitely large number for x and then square that, that denominator is going to become huge, which means that the horizontal asymptote is going to approach 0. Now what might confuse some people is that we look for the degree of the numerator and the degree of the denominator. Since there's no x in the numerator, it might be confusing. But without an x there, we can always assume that there is a 4x to the 0 power, which is just 4 times 1 in the numerator. So the numerator really has a degree of 0 and the denominator a degree of 2. When the degree of the denominator is larger, then the horizontal asymptote will always be 0. So option D says two vertical asymptotes at x equals plus or minus 1, but no horizontal asymptote. And that's not true. There is a horizontal asymptote when y is equal to 0, and that is the x-axis. So the answer would be C to question number 8. And we'll continue in the next video.